The construction of a traditional log cabin destined for Germany begins in Siberia, where high-quality, kiln-dried spruce logs are carefully selected. These logs range in diameter from 46 to 50 centimeters and are thoroughly dried to reduce moisture content, minimizing future shrinkage and deformation during settling. This particular house features a hybrid design, built using two construction techniques. One half is timber frame, while the other is handcrafted log, utilizing the Canadian notch system. The logs are joined with a saddle notch corner and a lunar groove along their length. As the house settles, these grooves compress the insulation and seal the joints more tightly, ensuring improved thermal performance. A standout feature of the interior is a massive tree trunk integrated as a central element, around which the home is symbolically and architecturally built. This becomes the heart of the living area, which includes a cozy fireplace zone, an open ceiling stretching to the roof, and custom integrated lighting among the branches, providing a soft, diffused glow. The log kitchen walls are specially shaved flat to facilitate the installation of modern kitchen furniture. Due to the differing settling behaviors between vertical posts, which do not settle, and horizontal log walls, which do settle, adjustable jacks are installed under the vertical supports. These jacks can be lowered gradually, allowing the frame to follow the natural settling of the log portion without structural stress. For the first time in this project, solid glulam wood panels are used as flooring and ceilings. These panels, up to 3 meters wide and 12 meters long, act like thick plywood slabs and are fitted into pre-cut rebates along the perimeter of each room for secure mounting. Every structural element is precisely labeled and documented. After the house is fully assembled and tested in Siberia, it is disassembled and packed onto pallets. These are then loaded into trucks bound for Germany, ensuring every piece arrives in perfect order for reassembly on site. This blend of traditional craftsmanship and modern engineering results in a warm, durable, and architecturally stunning home, crafted in Siberia, tailored for German comfort. The hardwood lumber process begins by sorting saw logs into grades to ensure consistent quality. Logs are sent to the debarking station to remove bark, then processed in the sawmill where the saw filing department keeps blades sharp for clean cuts. Boards are edged to trim irregular sides and pass through a double-end trimmer to achieve uniform length. Grading follows to evaluate quality, and lumber moves to the green chain for sorting and stacking. Lumber is sticked using grooved, non-tannic sticks and placed in air sheds to promote airflow and prevent staining. Ends are sealed with wax to reduce splitting. Kiln drying is carefully controlled by experienced operators who follow specific schedules for each wood species. Moisture and internal stress are checked before planing. Accurate tallying ensures transparency and trust. Finally, the maintenance department upholds machinery performance, supporting the production of high-quality, consistently packaged hardwood lumber Katahdin cedar log homes processes logs by drying them, shaping them in a planer mill, and then using a computerized house line for precise cuts, drilling, and labeling. This ensures easy assembly. Bearcore panel production process at PT Phoenix Agung Pratama. The production of Bearcore panels at PT Phoenix Agung Pratama begins with carefully selected Albazia falcata wood, known for its lightweight properties and fast growth, making it highly suitable for engineered wood panels. The raw logs are initially sawn into small rectangular blocks, which are then kiln-dried until the moisture content is reduced to a maximum of 12%. This step is essential to enhance dimensional stability and ensure a strong adhesive bond. After drying, the blocks are processed into narrow strips. These strips are lined edge to edge and glued using polyvinyl acetate adhesive, which is widely used for its environmental friendliness and strong bonding characteristics. The glued strips are arranged in a continuous layer, forming the core structure of the panel. The glued assembly is then sent through a hot press, where high pressure and temperature are applied to bond the strips firmly together, creating a solid and uniform core. Once pressed, the panels are cooled and precisely trimmed to reach the standard size of 13.2 millimeters thickness, 2,480 millimeters length, and 1,260 millimeters width. The final panels are inspected for quality, including strength, surface smoothness, and dimensional accuracy. They are then stacked and prepared for lamination or shipment. Bearcore panels are commonly used in door manufacturing, furniture components, and other wood-based constructions due to their strength-to-weight ratio and consistent quality. Workers operate advanced firewood processing machines and large chainsaw systems to efficiently cut and split wood. First, they feed logs or tree trunks into the machine's loading area or cutting table. Then, the workers push the wood directly toward the cutting blade. A powerful circular saw or chainsaw cuts the wood into smaller sections. Next, the wood pieces are moved by the workers to the splitting system, where a hydraulic blade splits them into uniform firewood. This automated process significantly increases productivity, reduces manual labor, and ensures consistent size and quality in the final firewood product. Coir geotextile production begins with the removal of husks from coconuts. These husks are soaked in water to soften the embedded fibers, making extraction easier. Once adequately softened, a mechanical process is used to extract the fibers from the husks without causing damage. The fibers are then thoroughly cleaned to remove impurities and are graded by length, thickness, and overall quality. High-speed machines twist and spin the coir fibers into strong, durable ropes. These ropes are then woven into coir geotextile rolls using precision machinery. The weaving process is tailored to meet the strength and permeability specifications required for erosion control and soil stabilization. Coir geotextiles are biodegradable, sustainable, and provide effective soil reinforcement. This eco-friendly production process integrates traditional natural materials with modern manufacturing technologies to support environmental restoration and land management efforts. The yarn process in ring spinning begins with raw cotton, which undergoes several stages to transform it into a single yarn. First, the raw cotton is fed into the blowing section where impurities such as dirt and seeds are removed, and the fibers are separated. After this, the cotton is moved to the carding process, where the fibers are further straightened and formed into a sliver, a continuous strand of loose fibers. Next, the sliver is passed through the drawing process, where it is elongated and blended with other slivers to ensure uniformity in the fiber length and thickness. The sliver is then combined into a finer form, known as roving, during the roving process. This creates a thinner, more elongated strand of fibers which is ready for spinning. In the ring spinning stage, the roving is twisted into yarn using a spindle. The spinning process imparts strength and consistency to the yarn by twisting the fibers together. The yarn is then wound onto bobbins in the winding phase, ensuring the yarn is neatly coiled for further use. The final product is a single yarn that is smooth, strong, and ready for weaving or knitting into fabric.